Hi guys. Okay, so tonight we're going to look at, I don't know if you remember me saying, but whatever you work on is going to be based on your progress in class. So I noticed that we really need to go into some detail and just specific on different types of exponents, okay? So in order for us to be successful with our exponents, we need to really understand them. So I'm going to go back, and today we're going to be focusing on dividing exponents. And we're only going to be dividing exponents with the same base. Okay, so pause your video and I want you to copy this down. Everything that is down on this slide, I want you to copy it down. So I want you to copy down your objective, which says I will divide problems with exponents. And then I want you to copy down the explanation of dividing exponents with the same base. So you're going to write all of this down and then push play when you're ready to continue. Okay, hopefully you guys have copied it all down. And we're just going to go over it super quick. So this is a to the n divided by a to the m. Okay, so we will see them written in this form. Okay, so this is your numerator and this is your denominator. And a is our base. N and m are our exponents. So as long as we have the same base, we can solve this by using subtraction. So my answer will be a to the n minus m. So we're always going to subtract the denominator exponent from the numerator exponent. Here we have it in numbers, and I'll write it the way you're going to see it here. 2 to the 6 over 2 to the 2 cubed. We're going to take our base, and we're going to take our numerator exponent and subtract the denominator exponent. So this, I can actually come up with an answer. 6 minus 3 is 3. So this becomes 2 to the third power, which is 2 times 2 times 2, which is equal to 4 times 2 is 8. Okay? So we're going to do a couple. We'll do 3. One is I do. I want you to watch. The next one is we do together. And the third one is you do. You'll do it on your own. Hopefully you get the right answer. All right. Oh, look at both of these have 5 as the same base. So my base for problem number 1 is 5. So I'm going to go ahead and I'm going to take my base over here, and then I'm going to write my exponent here. And this looks like a 4, I'm sorry. So 2 minus 4. And then I'm going to go ahead and do that subtraction. So 5 to the 2 minus 4 is going to give me the same base of 5, but this is going to be a negative 2. Now I'm going to use what I remember from my negative exponents. We're not supposed to have any. And I'm going to make this a fraction over 5 to the second, right? So 5 to the second is 5 times 5, which is 25, correct? So this becomes 1 over 25. Super simple, right? Go ahead and pause your video and write this down. This was the I do. This one here is the we do. And you're going to do it with me, but first I want you to pause and copy this down. When you're ready, push play, and we'll do the we do together. Okay. Again, our base is the same. This is a 5 and a 5, so I'm going to go vertical this time. So 5, I'm going to take my numerator's exponent, which is 3, and I'm going to subtract the denominator's exponent, which is 4. Okay, so this is going to equal 5 to the negative 1, right? I cannot have a negative as my exponent, so I'm going to turn it into a fraction, 5 to the 1, which is the same as 1 over 5. Right? Remember that rule of 1, anything to the 1 is itself. Here you have another one. This one should be super easy for you to do on your own. does not involve a negative exponent. You should have one answer. Go ahead and do it, and we will confirm that you have the right answer tomorrow. Push pause, solve the problem, and then we'll continue to the next segment. Okay, hope you're back. Ooh, these look scary, right? No, not really, because really all we're basically concerned with at first is this little exponent here. This becomes a fraction. So what I'm going to do is I'm going to break it up. I'm going to take these numbers and I'm going to say 2 over 5. And we're going to multiply by this exponent that has the same base. We have m to the 4th and m squared. This 2 over 5, I cannot simplify. I cannot reduce it. 2 and 5 are both prime numbers. So we're not going to mess with this. We're just going to leave it like it is. So I'm going to say that 2 over the 5 is the same. And I'm just going to bring it down over here. But I am going to look at this. This has the same base of m and an exponent. So I'm going to say m, this is my numerator, and I'm going to subtract my denominator's exponent. And this becomes m to the 4 minus 2, or m squared. Since I don't know the value of m squared, I'm going to go ahead and bring this to the top here, and this is my new answer. Pretty simple, huh? Well, this was the I do, so you should have watched. And I want you to push pause, copy this down, and when you're ready, we'll continue with the we do. This problem here is the we do. Yes, we do. We believe in you. Oh, sorry. So remember, when there's a variable by itself, it's just 1. And this exponent is also going to be 1, since anything to the 1 is itself. And we're going to solve this problem by simply 8 divided by 1 is going to be 8. So I know there's going to be nothing on the bottom. I'm going to bring this up to the top by saying k squared minus 1. That eliminates my fraction, right? Because this is all moved up to the top. And my answer is going to be 8. K squared minus 1 is k to the 1, right? 2 minus 1 is 1, which is simply 8k. Right? Very good. Last one here is the you do. So go ahead and see if you can solve this. This here, 8 over 6, just really quickly. Can you simplify 8 over 6? Is this a fraction that we can reduce? Think about it before you solve the problem, because that will affect your answer. Go ahead and write this down and solve the problem, and I will see you tomorrow. Have a great one.